everybody. Our topic today is introducing inferential statistics. I am Keshi Patricia Mere Somono, Professor of Educational Evaluation, Research and Statistics, Manda Zekiwe University. Today we are going to talk on the topic introducing inferential statistics. Our learning outcomes. At the end of the lecture, the students should be able to define statistics, mention two types of statistics, conceptualize the term inferential statistics, mention and explain with examples the types of inferential statistics, conceptualize educational statistics, discuss key aspects and applications of educational statistics. What is statistics? It is a science of organizing, analyzing, interpreting, and presenting data. It uses mathematical techniques to summarize and describe data, draw conclusions, and make predictions. It is used to communicate or present results and findings of our research. Types of statistics. There are descriptive statistics and inferential statistics. When we say descriptive statistics, what does it mean? They are used to describe and summarize data. Example is measures of central tendency, measures of dispersion, some measures of relationship. Example, correlation. Inferential statistics. Inferential statistics are those statistics used to make generalization or inferences. They are used to generalize from sample statistics to population parameters. Inferential statistics are used in educational research to test hypotheses, make predictions, estimations, comparisons, among others. We use them to move from sample statistics to population parameters and draw a conclusion. What are we really saying? When we say inferential statistics, we know that when you start a research, you are studying population. You identify population to be studied. But many times it is difficult to study the entire population. So what we do is to take part of the population for study, which we call sample. And of course, sample must be a representative of the population. So after studying sample, you have information, the statistics, the characteristics. But you have not come out to study the sample. What you come out to do ab initio is to study population. So you now have to go from the information from statistics, from sample to population. It is the inferential statistics that will help you do that. That's why when we talk of key issues in inferential statistics, we talk about population and sample. Population is the entire group being studied. A sample is a subset of the population used to make inferences to move to the population. We talk of parametric parameters versus statistics. A parameter is the numerical characteristics of the population. Example, mean. But when we say statistics, it is the numerical characteristics of the sample. Example, mean. So when we talk of statistics in terms of numerical value, we are referring to sample. When we say parameters, we are referring to the population characteristics. So we have types of inferential statistics that are broadly divided into two. We have the one we call parametric tests and non-parametric tests. Parametric tests or statistics are used when the researcher can make assumptions that the data were collected from a normally distributed population. They are used when data collected are at interval and ratio levels of measurement. Some examples of parametric tests are t-test, ANOVA, and COVA. See, there are a number of things we said now about the parametric test. We talked about parametric tests making use of data, interval and ratio data. We can recall that we have levels of measurement. So the highest level is ratio, followed by interval. So this high level of measurement are the data that we use in parametric tests. Then non-parametric tests. Non-parametric tests or statistics are tests used when the sample cannot be assumed to be drawn from normally distributed population. They are used for nominal and ordinal data. Examples include chi-square, Mann-Whitney test, and Ron's test. You see, there are two things that come out, level of measurement which you have explained. We now talk of normally distributed population. When we say that a population is normally distributed, it means that it can fall into a normal curve. A normal curve is a curve that is symmetrical about the mean. That is, it has the mean at the middle, and if you divide the curve into half, they will resemble themselves exactly. So, for parametric tests, we assume that the population falls into a normal curve. Non-parametric is not. And you see the data for non-parametric, it is nominal and ordinal, the lowest level of measurement. Data gotten from the lowest level of measurement, scale of measurement that we use. Now, what is educational statistics? It is the application of statistical methods and techniques in collection, organization, analysis, and interpretation of data in the field of education. It includes using the results and findings from our research to inform educational decision-making, policy, and practice. So that's educational statistics. There are key aspects of educational statistics, student assessment uses, and evaluation, analyzing students' achievements and progress, identifying areas of strength and weaknesses. Another thing we use it for is research, using statistical method to study educational issues, assessing the impact of educational interventions. Accountability is one of the applications in education, holding all stakeholders responsible for their supposed roles, evaluating and reporting on achievements, performance, progress, and outcome, all aiming at ensuring that institutions and individuals are working towards achieving their goal. Another use or application is program evaluation, evaluating the effectiveness of educational program, example, interventions in curriculum or professional development initiative. Accreditation, well, we all know what this one is, evaluating institution effectiveness, checking compliance with regulations. In accreditation, they check institutions' compliance with laid down regulations. So, what we have done today is to introduce inferential statistics, of which we are going to, other lectures will be based on inferential statistics. Thank you for watching, and thank you for listening.